All right, Trevor, given a quick recap of section 8.3, hopefully somewhere in your notes you found a chart similar to this, probably with my handwritten instead of typed up, but this is the exact one that you will have on your chapter 8 quiz. So this is what it's saying. To find the domain, whoa, that was really big. Let me try that again. How about this one? To find the domain, you take the denominator of your rational function and you set it not equal to 0. Okay, let's go ahead and just do a practice of that right away with this number 4. So we take our denominator, x minus 5, and we set it not equal to 0. So the domain of this number 4 right here is x is not equal to 5. Okay, next. Discontinuities. You take your denominator and you set it equal to 0. Well, we already took our denominator and set it not equal to 0, so it's the same thing. We just change our not equal to an equal sign. So x equals 5. This is exactly what you'll have to do on your quiz. You'll have to find these things. Oh, before we move on from discontinuities, though, we have to be able to say whether this is a removable or a non-removable discontinuity. So it'll ask, what is the type of discontinuity? And you can look up on your notes, and they're defined there. But it's removable if there's a factor that's both in the numerator and in the denominator, because then it can cancel out. It can be removed. In this case, x equals 5 is there's not a factor of x minus 5 in the numerator, so this is called non-removable. Okay, now next, to find the x-intercept, you set your numerator equal to 0. Okay, my numerator here is negative 2x plus 6. I set that equal to 0, subtract 6, and divide by negative 2. So x equals 3 is my x-intercept. Next, y-intercept. To find the y-intercepts, you put 0 in for all of the x's. Okay, y-intercept. It can be in factored form or in expanded form from this. This one is just find the way it is. I put 0 in for all of the x's, and I get 6 over negative 5. Well, that's my y-intercept. You can write negative 2 times 0 plus 6 all over 0 minus 5, and then reduce it if it makes more sense to do it that way. 2 more. Vertical asymptotes. The vertical asymptotes are those vertical lines that my graph never touches, and we find them by just renaming any non-removable discontinuities. So I'm going to move my list over here. Vertical asymptotes, non-removable discontinuities. Well, we have one of those. It's x equals 5, because that is the non-removable discontinuities. Sometimes there'll be 2, or sometimes there'll be none. All right, and our last one, horizontal asymptotes. So this one maybe takes the most work. You have to first select the leading terms. And the leading terms are just like in expanded form, not in factored form, the highest terms. So in this case, it's negative 2x over x. And next it says, reduce that fraction. Okay, I reduce that down to negative 2. From there, there's 3 different options. Sometimes it'll be like this example where it's just a constant. So my x's went all the way away, and I'm left with just y equals negative 2. Well, then that's your horizontal asymptote. If I were to repeat this process for this number 5 down here, my leading terms, so horizontal asymptote, y equals x over x squared, reduce that, I get 1 over x. In this case, and look carefully at your notes or at the notes that I sent you, the x is left in the denominator. And so we're thinking as x gets really, really big, what's happening to this number? So I think, well, what is 1 divided by 10? And what is 1 divided by 100? And 1 divided by 1,000, or even a bigger number? And 1 divided by a really big number is really close to 0. So when that's the case, if x is left in the denominator, even if it's like a 10 in the numerator, 10 divided by 100,000 is still really close to 0. So my horizontal asymptote would be 0. That's option number 2. It says up there there's 3 options. Your third option would be like on number 6 here, leading terms, x squared over x. When you reduce those, you get just x, or you can think of it as x over 1 if it's helpful. In this case, the variable is left in the numerator. And so as x gets really, really big, you're taking a big number and dividing it by 1, and that number is just getting bigger. So like 10 divided by 1 is 10. 100 divided by 1 is 100, and 1,000,000 divided by 1 is 1,000,000. So that number is getting bigger and bigger and bigger. It's not going to one certain number. So we say there is no horizontal asymptote, or we could just put none. So this 3 option thing, it's either going to be a constant because your x's go all the way away. It's going to be y equals 0 because after you take your leading terms and reduce, you're left with an x in the denominator. Or it's going to be none, because after you take your leading terms and reduced, you're left with a variable in the numerator. Hope running through that example helps. Again, we have a few more we can do when I see you in person. Yeah, so good luck.